Hiya guys, and welcome back to Wade's Workshop. So yeah, I think I've been out of the shed for a couple of weeks. I was away last weekend in Bristol. What a lovely city that is. Anyway, that's another story. So I didn't manage to get in the shed. So it's been a couple of weeks since I've even been in the workshop. Weather's been a bit wet and horrible and what have you. It's sort of coming up to springtime. Evenings are drawing out. We may get a bit more time in the shed. Who knows? So with that said, finally I ordered the Piston O-rings, so for the engine that are going to go on the piston. So right, okay. So I use this sperm quite a bit for, well, all the little bearings and bits and pieces. These were, here we are, Simply bearings I got them from. Yeah, so basically online in the UK here, Simply bearings. They do all sorts of belts, bearings, pulleys, Piston O-rings, all sorts of things. So obviously if this video comes out in, you know, and what have you, and in 12 months time somebody wants to know, that's the website I use for all the bearings in this, bearings, belts, pulleys, and obviously the Piston O-rings. It's really simple to use. So I made a complete change. So a box has arrived from Alibaba or AliExpress or whatever it is. Didn't take long, just over a week. And what I've ordered, I'll try and explain it briefly. So for the spark system, the original plan designs were points, condenser, you know, capacitor, big battery, that sort of idea, to run the spark in a conventional manner. Now, what I've decided to do is to change that up as well, and I'm going for electronic ignition. So into the 21st century with this, we got a cam belt instead of cam gears, and we got variable valve timing on it. Well, not variable, but easily adjustable valve timing. So we're going to have electronic ignition as well, which I can again adjust by turning basically what's going to be a circular cam. So first of all, I've got, now this is, I believe, model engine stuff. So there's a little Hall effect sensor, so it's basically going to pick up on a disc with a magnet in it. And then I'm not going to open the packet right now. So designed for the spark plug I've got, basically a little box of tricks. In there is an HT lead braided with a spark plug cap, a set of power leads that go off to a battery. Tie in with the idea of using just one of my DeWalt 18-volt batteries. We'll see how it goes with that. I think this charger, I will have to look. No, I can't. 6 to 14.4, so I'll have to think again on that one. So yeah, I'd like to have a rechargeable battery in it. So yeah, one cable goes off and plugs into the Hall effect sensor, which tells it when to spark. One cable, 2 wires go off to the power source, and a third cable, not sure. So I'm not sure what it does. In fact, there are 3 cables in here. So I'm going to have to work out how to wire this up. I have no idea, but trial and error, and I'm sure I'll work it out eventually. So it will have electronic ignition. So I just thought it makes life so much easier than, I think I paid 30 quid, something like that for that. By the time I buy a coil, condenser and a set of points, which are getting harder to get hold of nowadays, I've got that. It's a RC model aircraft or model engine kit, and it's designed to work with the correct spark plug, the one that's in this engine. So yeah, so that just it was a no-brainer. It makes everything really simple, apart from learning how to wire it up. I have no idea. Right, so with that said, I did get a spare. When I ordered it first off, I thought, well, that's cheap. It was only about £4.50 and coming all the way from China, but that was just for the Hall effect sensor. So I have a spare one because when you buy the kit, another one comes in it. So that's great news. So now that I've got these O-rings, I'm going to start looking at the cylinder. I've already honed the cylinder and polished it, so it's a smooth finish, not like a typical honed finish. Because it won't be running on rings, it'll be running on O-rings as opposed to cast iron rings or what have you. So we don't want the cross hatching in the bore. We want it to be smooth and shiny so it doesn't destroy the surface of the O-rings. With that said, I need to turn up basically a bit of experimental work, a piece of aluminium that's going to be the final OD of the piston to fit the bore. So maybe 2 thou clearance perhaps on what the bore size is. and then I need to work out the groove depth to get that nice bit and seal with an O-ring in. Now I got a pack of 10. If I could have bought like 2, 5, but to get the free postage it was worth buying 10, and then I got free postage, so it didn't make much difference. So I've got plenty to play with for experimenting anyway. So that said, let's go to the lathe, see if I can find a piece of aluminium of an appropriate, I can't speak this morning, dear God, what's wrong with you, eh? I'll go to the lathe, I'll pick up a piece of appropriate aluminium, that's a bit of a tongue twister, but I got there in the end, and we'll see what we can do experiment-wise just to get the final dimensions for what this piston and groove are going to be. Enjoy. So I've been putting this off for ages. I've ordered the O-rings. And they are, obviously this being an Imperial engine, or Imperial sized, but closest O-rings I can get are 1.6 section, and their OD is 22.3 millimeters. So I've been holding this for probably 15 minutes. Just going gently at it. I'm probably about every... Okay, measurement at the moment, 22.24. So, I'm not going to go to the full 22.3. I'm going to go to about 22.27, something like that. Just to leave that little bit of interference on the O-ring, and then when I do the groove, there's going to be a lot of experimenting. So I bought a pack of 10 O-rings anyway. So when I do the groove in the piston, to take the O-ring, the Viton O-ring, there's going to be a bit of jiggering about with the depth of the O-ring groove, which is going to be fun. So measuring up either end of the bore in here, and you can see I'm just letting the stones come out just, you know, 2-3 mil. I can see the top, and I'm coming up basically level with that black there, and I can see them sticking out the bottom, so I'm close. I got a bit of WD-40 liquid on the stones, and my bore is parallel to within 0.0012. Is hard to measure much closer than that with a telescopic, but so, you know, one end was measuring, let's say 22.23, and the other end might have been measuring or 231, and the other end might have been measuring 22.233, something like that, but that's all in the feel. So yeah, we're just it's monotonous, it's time consuming. The finish in there is good. I mean, it's a very fine hone, this. With it running on an O-ring, I do want to polish it afterwards, so I think that's going to be a case of a bit of Scotch-Brite on a stick. Does that sound right? I don't know. We'll see. Trying to get the best view. As you can see, it's not mirror finish in there, but the finish is good. Yeah, I think we're there. So it's measuring up at 22.275, near enough. So 22.3 is the OD of the O-rings. So I think we're okay. I'm going to leave it there. So I just put a torch in the back of it just to shine through the bore, but yeah, it's good. You know, I put a piece of aluminium to one side, and I thought, yeah, that's going to make the piston, and that's like waving a sausage in the Albert Hall, so that's not going to work. The trouble is, I think the next size up I got in aluminium in stock at the moment is like 2 inches, or 50 mil, something like that. So let's see if I'm going to have to turn a big chunk of that down, but hey-ho, that's the way it goes. So it's a little bit hairy. Let me just stop it a second. So yeah, I'm having to hold reverse jaws. I can't even hold it in the middle ones. It's just that weird size that the chuck doesn't take on here. So not side loading at all. I can't even face it off. I wouldn't dare by it sticking out that far. So I'm going to center drill it, put a center in it, and then I'm going to rough down just an area at this end so I can hold on the diameter safely, and then we'll work on the other end and take a big chunk of material off this. So let's see how much we can hog off at once just for a laugh, shall we? So straight off the bat, 1.5 mil aside, so taking 3 mil off the OD, and we're running a 723. Yeah, I've set my DRO, so 1.5 mil cut. Swarf's not breaking, but it's not nasty stringy spitting out everywhere, it's just curling up, so expecting a bird's nest anytime soon. The second cut, banged it up to 5 mil off in one cut. So yeah, it's a bit smelly. I got a bit of WD-40 on this, stop it welding. I'm now running at 900 RPM, and that's 2.5 mil a side. So yeah, you know, I'm not going to overwork it, but this little Warco lathe, you know, it can work when you want it to. Actually, my swarf is all dropping straight down onto my floor now in a big heap, so I'm standing well back. Just a last scratch cut, just take any spring out, and then I'm going to chop this bit of bar off, and I've got basically my raw stock. So I've skimmed this down over half its length. I've been quite delicate with this, till I got to the point where it would just slip in the bore. Now, I tried both ends of the bore. So I just put a 2 thou cut on, or no, a 1 thou cut on to give me 2 thou clearance on that. My DRO doesn't do very well in Imperial, so it's a sort of clunky. So I just brought a clock into play, and I've gone basically 1/4 mil. 0.02 on the dial there. It's a metric clock. I got on a little mag stand there. I really must get a little mag base to put a standard clock in, then I can swap between Imperial and metric. But yeah, so that's against the tool post. Put the cut on, and oh, no reason why I can't. Put a bit of fluid on. I'm shaking about, doing 2 jobs at once, and just taking that final, as you can see, 2 thou cut. Hopefully that'll be it to the theoretical diameter that the piston should be in the bore. So, what our final dimension we did come out with. Okay, 0.87295. So 0.873 was where the theoretical is. So yeah, I think we're close enough to 2 thou underneath the nominal 875. Of course, next thing, I've just put that down carefully. Let's just try the cylinder on there, and it should not be tight, but it shouldn't be slop. Well, goes all the way in. Okay, that's good news. Just check it. Ooh, put a dent in it, eh? Yeah. Okay, my bore's nice and parallel anyway. Right, so that's my sort of outside of the, replicated what the outside of the piston's going to be. If we get real lucky, we might even end up being able to use this piece. So the next thing I need to do is look at the groove, look at the O-ring and look at the groove, what the theoretical depth of groove should be. I think what I'm going to do is creep up on it, keep taking a bit more. I'm going to keep the clock on here on the tool post. I may have to grind a tool up. Well, I pretty much will. Shame I haven't got a cutter grinder that's in commission. But I'll have to grind a little grooving tool up. I wonder if my parting tool, if that's narrower than the O-ring, we may be on a winner. I think I'd rather do it with high-speed steel. Or do I just put a new tip in there and go for glory? I can always put a little groove on the end, if I'm happy with it, I'll then put a groove to the same depth, the right distance back from the end, part off the initial test groove and go from there. I'm just wondering, should I put a centre in the piston? Should I put just a small centre in the end of it, just to locate it solid while I'm digging into it, because I am quite a bit out from the chuck here, just to keep it solid while I'm pushing on it, as it were, and then deliberately go back by the depth of that centre for my sort of finished groove, whatever distance it's got to be, but deliberately come back and then face the end off then to get rid of the centre after. I think that might be a wise move at this point. So yeah, just thinking out loud, guys. Let's see what tool I've got first, but I think I will get a small centre drill hole in the end of there. We'll do that first. So my O-rings are 62.5 thou section, and my parting tool is just a hair under 60 thou wide. So I grooved it out 56 thou deep from touch, and then came back out, flanked it by 2 mil, so 2 thou, moved forward and just grooved it out. And now thickness wise of my groove, my O-ring slips in the groove. I've cleaned it all up, I've just deburred across the top edge, and I'm just going to pop that O-ring in the groove, and that seems to have sat down in there. Now I'm going to have a devil's own job getting that out, but this is purely experimental. This is not the final groove, this is not the final O-ring, so it seems to sit down in that groove quite nicely. So moment of truth, let's just bring the tool out of the way, let's just, cool, that's firm. May need to go a little deeper. Well, it does go on. Ooh. You know what? It does. Cool. You know what? I think those are the dimensions I'm going to stick with. So, I think if I did the same thing, you know, wherever the distance back, so I'm going to call that where I parted off, that position in the groove, which I've got a 0 for on my DRO, and then I'm going to step back whatever the appropriate distance is and put another groove in, face it off to the back of this original O-ring groove, and we may have something that's going to work. Okay, so yeah, thinking out loud, guys, my battery's about to die. My camera's, the little battery symbol has gone red, so we may have lost you already. No, I think we still got you, but I'm going to do the groove again. I will show you me doing the next groove. So new battery in. The length is 94 thou. I just did a groove and I bumped the clock and I'm not sure where it was, so I've just moved back another 94. So first groove. Now, I don't know whether to put 2 O-rings in or 1. I really don't know. I'm just going to have to go with the flow. I'll put 2 grooves in, and if I only need 1 O-ring, then I'll only put 1 in. So that's my thinking there. So here we go. Clock set at 0. Right, leave it there. Get the swarf out of the way. So now flank that 2 thou or 0.05 on my DRO. There we are. And back into the same depth, which is there. Okay, groove number 1. So I need to move 3.9 mil now. Which is my 1.5. Oh, that's too much. There we go. And yeah, my clock. Let's just reset my clock when I get a touch on 0. Close, it's close. 50. That's it. And blanket 0.05. Back into the same reading. Same gap. It's there. Okay, that's 2 grooves in place. That was a bit hairy. I did 1 practice groove originally that you saw to get the size. I did another one, bumped the clock at the right depth back. So I've just done a further 2 now. I'll face off the mistakey bits. So if I bring you around, I'll show you where I am. So I can break this setup down now, I think. Or do I try it first with the O-ring in one of the grooves and then the O-ring in the other one? You know what, that's what I'm going to do. Before I break the setup down altogether, I'm just going to triangular needle file. There we are. Okay, I'm not going to chamfer the top of the grooves. You can see them now, just about. That first one's not going to exist, nor that one. Okay, so just break edge there, break edge there. And perhaps just a little bit of just to make sure we got no burrs. A really worn out bit of wet and dry, or emery I should say. Okay. That just had a slightest of tickles. Right, okay, so okay, it is clean. Right, so I'm going to try and put that O-ring now in the 3rd groove. There it is. It's not quite sitting. It's a little bit bindy. No, it's going in. It feels a little bit bindy in there compared to the original. It's in there. Right, let's just try the cylinder again. It's going on. Okay, that groove's good. I'm going to start with this. I'm just going to get the pick now down the side of the seal. Just get it to ruck up. There we are, and I've broken it. Okay, well that's absolutely fine. Thankfully I've got lots of sacrificial seals, so we'll say goodbye to that one. I think I've got my dimensions right. That seal fitted, the cylinder fitted nicely on with that seal in place. So now I can break the setup down. What you doing, eh? And do away with my clock, which is going up there behind the camera. Everything's happy. So I'm going to bring you round. Let's do that. Oh, focus. So groove number 1 here, that was purely to get a size. We knew we were going to face that off. Did the 2nd groove by stepping back 94 thou, which is what the drawing calls for. Put in the first trial, absolute rubbish. Bumped the clock while I was on it, lost my reading, not sure if I went deep enough or not, or too deep. So I'm going to face off right back to the front edge of the part here where my thumbnail is. Face it all back to there, and then these 2 grooves are going to be yeah, they're pretty much going to be the 2 grooves, and the wall thickness between these 2 should be approximately 94 thou, which is what it called for originally. Now that does put the lower ring a little bit closer up than it was to drawing, but I don't even know if I'm going to use the lower ring. Probably will during initial setup. If the friction's too great, we'll try it with 1, try it with 2, see how we get on, I suppose. So that's it, all faced off. Okay. So I'm not tempted to polish up the OD because I want it to hold a bit of oil on the surface. So I'm not worried about a super good finish on the OD of the piston because I want it to retain a little bit of oil. I suppose just break that top edge now. Don't want a chamfer on the top of the piston, just a broken edge. Don't want it sharp. Just get those grooves again. Okay. Right, that's the outside of the piston done. So I suppose what I'm going to do is go back to my drawing again, see what the overall length is, maybe leave, you know, 100th thou on the end, something like that, and then I can put it back up in a collet afterwards and face the bottom edge of the piston. Then I can look at, I've got my overall piston length. Then I will look at doing the innards, doing the hole in the outside, that sort of thing. Do I do the hole in the outside? No, because I've got to orientate the pocket in the inside at the same time as a hole in the outside, in the same orientation. So I got to go and have a look at the drawing and form a battle plan, guys. But so anyway, I've got 2 O-ring grooves in there now. Piston to size, the O-rings will fit. I did check the second one off camera, and that runs nice as well. I'm still undecided. I can get the cylinder on. I don't want to waste O-rings, so I haven't put 2 on. I can get the cylinder on nicely, whichever groove it's in, and it feels sort of right, but I haven't tried it with 2. But we'll cross that bridge when we come to it. So the overall length was 1 inch. Just parting it off, well, 25.8. Let's have a look at that. Another 6mm. Probably a good 70mm from the chuck here, but that parting tool seems to like it all right. Or grooving blade. I think I'll finish it off with a hacksaw. I don't want it flying around, and yeah, I'm just looking after the piece that I just put a bit of effort into. Well, there we are. There's my piston blank. So I need to face it off now, and there's a 750 diameter rebate under here, 250 deep. So that's going to be the next part of the process. Now, I thought about putting this in the collet chuck, but of course my ER32s don't go this big. They go to 22mm. So yeah, it's going to have to be the 3-jaw, I'm afraid. But it's really good, the 3-jaw on this. Depends on what size you're on, but I think I've been fortunate that I've got a Chinese 3-jaw that's accurate. So, and I do keep it clean, and you know, I don't go nuts with it. But yeah, so we got a fighting chance. And I've now got a bit of stock of a smaller size going forward. Well, even if I got to remake the piston, if I bugger it up, at least I've got the dimensions. So fun and games, boring this out. I got my boring bar up. I should have, or should be close now. I'll give it a measure after this cut. So, looking for a 3/4 OD, 6.35 deep. Now there is another bore below this, a 6.35. So I put a little undercut to save me having to face all the way through with a 10mm milling cut. I've just got a couple of mil deeper. So I'm looking for 750 here. Tools in the way. Caliber measurement to be sure, I'll be fine for this. 19.04. Okay, let's go to inches, see where I'm close. I think that's pretty close. Seven 745.5. Let's just do that again. Let's just check my calipers is on 0. Yes. So I'm looking for 750. Actually 749.5. I think I'll just run that cut again, call it a day. Let me just set 0 on my DRO. I want to face the bottom, so I'm just going to run that cut back and forth again. 6.35. back out. Notice how I go to the beginning now, or into the middle. Just go into that 6.35 depth. There. Lock carriage. Wind back out to my 0. Face the bottom of that hole. Or that bottom of that counterbore. Coming out to my 0. Not touching now. Not touching. Well, that's phenomenal. Okay, so that's the undercut in there. 1/4 inch deep, 3/4 diameter. I think the rest of the work on this now, I'm going to put a brake edge on the underside of the piston. I think I'll put a brake edge in that hole. The rest of the work is milling machine, I think. So I think we're very nearly there on the turning. Let's just sharpen the bottom edge of the piston. It isn't doing anything. Touch more. Okay. And I think I'll use a little bit of emery on the inside. Okay. I think that is the basis of the piston done. Tempted just to... Now, I'm not going to do any polishing on the piston. I want it to hold oil. I was going to relieve the bottom of the skirt, if we're going to call it a skirt. But because the gudgeon pin, for want of a better word, is like halfway down the piston, I don't think I need to do that. Okay, so I didn't have that very tight at all. Tight enough. So outside diameter's done, length's done, groove's done, overall length of the piston done, and a little counter bore in there, 750 diameter by, well, 1/4 inch, 6.35 I went for depth. And I did put the little 10mm cutter in the centre, as you can see, because there is going to be a slot in here, deeper in. This is the sort of last relief, but then there's a slot then to let the crank or the con rod wibble back and forth, and then obviously there's a cross hole, and then at the same time there's 2 tapped holes in there which are for grub screws which hold the gudgeon pin in, and then there's various other bits. There's a little copper sleeve, I believe, or it's got a hole down it. There's various bits and bobs that are going to help with lubricating it all. So that's all on the drawing, but that's my piston pretty much complete there, as far as the turning is concerned. Okay, so here's my piston in the bore. Okay, and it literally, you know, it will sort of fall under its own weight. But we're talking, you know, if I just push it there, I mean, it just sort of settles, and if I just touch it, it's gone and it's out the other end, and I can push it back out again. Yeah, so I think I've got the fits of the piston itself right. I might even keep it stored inside here to stop me damaging this piece of aluminium. Happy. Next steps will be milling machine, but I think, guys, that's going to be for another day. I think that's about it for this one. Nice to have that, well, I'll call it a spark pack come in. Yeah, I'll have to design a rotating disc with a magnet in it that can be adjusted on the camshaft. That's in the offing. We're starting to get together now. It's, you know, it's coming along. So I have been carrying on with the mini lathe. I did manage to order some multi-core cable. I think it was 8 core. So I am getting along with the wiring on that, but it's very slow. I'm sort of doing it in a deliberate manner, trying to organise things just to get it so that the wiring is tidy. It's probably my weak point, wiring, but you know, if I take my time, I can get it reasonable. And the only person that's got to work on it and look at it is me, but you guys are going to see it along the way. And yeah, I know I'm wide open to criticism on it, but that's absolutely fine. I got broad shoulders. So that said, you guys seem to enjoy the Pembroke Castle out in that I put up the other week. So yeah, if I go anywhere else interesting or what have you. I've got a new phone now. I've moved up. I was on an old iPhone 6 and it came to the end of its days. It had a battery life of about 35 seconds. So I haven't splashed out. I've just gone for the i11 anyway. Nothing stupidly priced. So, but the cameras on those are much better. So I'll have a camera on me when I'm out and about that's a bit more appropriate for YouTube videos. Again, maybe a bit better quality, and I will remember to use landscape and not portrait because, yeah, it's not me, phones, to be honest. The technology in them nowadays, I do have emails and stuff on them, but yeah, I'm fine on a laptop. Not too bad at editing nowadays. It's improved a lot over the years. But yeah, I'll have to start playing with using phone footage when I'm out and about, just to get some interesting stuff. So with that said, guys, thank you so much for watching. Thanks for subscribing. We're nearly on the 13,000 mark now, so we're getting there. Another little landmark. Anyway, thanks for watching, subscribing, and we'll see you all soon. Cheers, guys.